Mr. Heffer here. Here's a short video on how to do a ray diagram for a diverging lens. So here we got a 4 centimeter tall hobbit standing 8 centimeters in front of a convex, sorry, actually this is concave diverging lens. Okay, a focal length 2 centimeters. Okay, so we're going to use at least 2 rays to find the image location. So the first ray would come parallel to the principal axis, like this, and then it would diverge away from the focal point, like this. It's going to come in like that. There we go. So now what you need to do for diverging lenses is you have to draw the extension line backwards through the focal point like this. And to show that it's an extension line, it's always a good idea to turn it into a dashed line like this. There we go. Now the second ray I'm going to use is the easiest one. It's going to go through the optical center of the lens like this, and it's just not going to bend or refract at all. It's just going to keep going. So now we found out where our image is located. Our image is going to be right there, and it's going to be tiny. There we go, a little tiny image. Very hard to see now. Now if you do decide to go for a third ray, you can aim a ray at the focal length like this. Okay, sorry, you can aim a ray from the head towards the focal point right over here. But when it hits the lens here, it's going to refract or bend so that it ends up moving parallel like this. So now once again you have to draw an extension line back. So we're just going to draw an extension line back right there. And you can see when we draw the extension line, the dashed extension line will match up with the other two right here. And so that's where our image is going to be. It's going to be a tiny little image right there. Okay. So it looks about to be maybe 1/4 the size, and it looks to be not even 2 meters away, or 2 centimeters away, sorry. Let's change these to centimeters. Now let's use the equation to find out where it's located. Okay, so we're going down to the lens maker's equation right here, and we're going to pop it in and fill it in. So now, because this is a diverging lens, we're using the other focal length, so we'll be using -2 centimeters instead of 2 centimeters. So right here for the focal length, -2 centimeters, there we go. The object distance was 8 centimeters. And so we're just going to bring the 1/8 over to the other side. Let's just do that. There we go. Okay, so the opposite of adding is subtracting, so we're going to subtract the 1/8. Now 1/2 and 1/8 have a common denominator of 1/8. So that's pretty easy. So it's going to be 4/8. There we go. So we got -4/8. Subtract 1/8, we're going to get -5/8 altogether. Alright, so it's going to be on the other side there, -5/8. Come on, there we go. Alright, so if we flip that over, we are going to get an image distance of 8/5, -8/5. So let's just let's fix that. Alright, so -8 centimeters over 5. Okay, or 8 divided by 5, you can throw it on your calculator unless you already know what the answer is 1.6, so 1.6 centimeters. So let's just double check that. I think that looks right to me. If you take a look at the picture, that looks like about 1.6 centimeters in front of the lens. Because that's 2 centimeters right here at this focal point, and that looks about 1.6 right there. So that's good. We got it. Awesome. So now the other thing we have to do is find the magnification and the image height. Okay, so we're just going to grab the magnification equation here and pop in our values. So the object height was, let's just double check that. It was 4 centimeters. There we go, 4 centimeters. The object distance was 8 centimeters, and we got the image distance to be 1.6 centimeters. But on the opposite side, so that's a negative 1.6. There we go. Alright, so if we just grab these two parts of the equation, we can calculate the height. So we're just going to cross multiply the 4 centimeters over to the other side. There we go. Alright, and so we got two negatives, which makes a positive, so positive 1.6, and then 4 over 8 is just 1/2, so half of 1.6 is 0.8, so we're going to get positive 0.8 centimeters, and you don't have to write the positive if you don't want to. So our image height is going to be 0.8 centimeters high, and then if we grab two other parts of this equation here, okay, there we go. Drop that over there. Okay. Alright, so we're going to get rid of this part right here. There we go. So we got negative 1.6 divided by 8. So you can use your calculator if you want for that. So 1.6 divided by 8, that's 0.2. So, and it's two negatives make a positive, so that's going to be 0.2 times. Okay, or 20% of what it used to be. So if you want to put 0.20, it might be easier to see that. Alright, so, or you could say that's going to be 1/5 of what it used to be. There we go. Okay, so it's going to be 5 times smaller than it used to be. You can double check that. Just grab the image there, and let's just check. We copy and paste the image up a few times. There we go. So far we got 3, 4, and yeah, approximately 5. It's not perfect because it's a diagram. But yeah, definitely it's about 0.2 times what it used to be. It's only 0.8 centimeters tall, and it's located at negative 1.6 centimeters. So I hope this helped you out with your diverging lens diagrams. Good luck.